We're going to get started in just one more minute and give people some time to get connected. Feel free to share in the chat where you're joining from today. Welcome, everyone, and thank you so much for joining. Today's workshop is going to be covering the AI Fairness 360 Toolkit. We're going to look at how to identify and remove bias from AI models. This workshop is part of our IBM Developer Black History Month event series. It had to unfortunately get rescheduled, but we're here to cover everything today. So if you weren't able to attend our panel discussion, I'll share a link so that you'll all be able to watch the playback from that as well. So just a few pieces of housekeeping before we get started. So I'm going to introduce myself, and I encourage you all to introduce yourself as well. We're all a part of each other's professional development communities now, and I want to give you a chance to connect with me, and more importantly, a chance to connect with each other as well, while we're all doing everything virtually. So my name is Jenna. My pronouns are she, her. I'm a cloud developer advocate at IBM. I'm currently joining from Detroit, which is where I'm from. I joined IBM in Austin, and my team is/was in New York. So we're kind of all spread out now since we've all been working remotely over the past year. So something I love are my dogs. You may or may not hear them screeching in the background occasionally during our time together here. Hopefully not. And a quirk, so something that's uniquely weird or different about you. So something that's uniquely weird or different about me is I have an obsession with tuna melts and tuna sandwiches. If it's on a menu, I feel compelled to order it, or I feel like I'm missing out. And if it's not very good, I basically judge everything on the menu based on how much love and effort a restaurant puts into their tuna sandwich. So that's a little bit about me. Feel free to share. Like I said, it's some information about you. Introduce yourself in the chat while I go over a few pieces of housekeeping before we get started. So if you haven't already, you'll see a check-in button at the bottom here. So that is going to actually take you to the IBM Cloud login page. If you want to follow along with this workshop at home, you will need to be logged into your IBM Cloud account. If you don't have one already, I will show you how to get started. It is completely free to use. You'll never be charged at any particular point in time. It's not like a temporary trial. It's a free account that you'll be able to use as long as you wish. Also, if you scroll to the very top of the chat, I've included all of the links there as well. So if you miss one, just go ahead and scroll to the top of the chat and you'll be able to access the links there. So this is the link to create an IBM Cloud account. Oh, I'm sorry. This is the slide, the link to the slides. My apologies. So I have all of the links and all of the information available within the slide deck. You all have access to the slide deck. Feel free to comment anywhere that's not clear. I have comments turned on for all of you. But this is the link to the slides. Again, it's at the very top of the chat as well. So this event is being recorded, and the live stream will be available at the link you all used to join with today. So this same URL that you're joining with now, this live stream will automatically convert into a recording and be available to all of you immediately following the end of the event. So this is the cloud link. So again, if you click the button at the bottom of your screen as well, that will also take you to creating the link to create a cloud account or log in if you already have one. So there's a few things that we'll need today. The first one will be an IBM Cloud account. The second one will be the identify and remove bias code pattern that will give you access to the GitHub repository, and that's where you'll be accessing the data sets we'll be using today from. This is also the link to the IBM AI Fairness 360 Toolkit. So we have a few of the AI 360 toolkits available. I'll be reviewing those with you in just a minute, but this is the link to the toolkit if you'd like to check it out. I included a link here for you to do that. And if you'd like to, like I said, I'm glad to see so many familiar faces returning. And for those of you that are new, I'm so glad to meet you all. Feel free to connect with me. I'm on all social platforms. My handle's Jwritten. So you'll be able to find me anywhere if you want to connect and follow me on social. So I have a few resources here. I want to do a temperature check. So the first thing that I want to ask all of you, go ahead, feel free to post in the chat, is what technologies are you currently working with? So are you working in Python? Are you working in JavaScript or React? Are you working in R because you're doing more data science? Just kind of want to get a gauge, a feel for what you're all working with. And then also want to find out what kind of companies you're all working at. So I'm going to start a poll here. Just a second. So feel free to add that to the chat. Oops. Okay, cool. And I've just started a poll for all of you as well. I want to feel for what kind of companies are you working at. So the options are enterprise, if you're working at a larger company like Google or IBM or Amazon, a startup, maybe a company like Twilio, or maybe more established startup, early stage startup, maybe a brand new company. They're still get in their early rounds of funding, and if you're a student and you're still learning. So feel free to take a minute to fill out the information here on the poll. Very cool. So I see a lot of students here. See some enterprise professionals as well. So while you're all filling out the poll, I wanted to, one of the things that I've started doing is recommending some learning tutorials for all of you. So IBM has a lot of free learning resources that you can learn professional badges for. So for instance, we have a different cloud native development badges. We have data science badges. We have all different kinds. We have design badges. So I've been starting to pair badges with the content to help you all get access to free learning that you can earn badges and credentials from, and then you'll be able to actually add them to your social platforms or your resume, and show potential employers that you have a good foundational learning of these areas of technology, and that you've gotten hands-on and been able to get your hands dirty a little bit working with these technologies. So the first badge I have here for you all is the Data Science Foundations badge. Each of these badges is also comprised of three short courses. So each course you'll earn a badge, and then once you earn all three, you'll earn the Data Science Foundations badge. So it's actually really nice because you're receiving a number of badges that you can add to your LinkedIn profile or GitHub. The next badge I have here is the Applied Data Science with Python. So this is a really nice badge. Again, it's a set of three. It allows you to get more hands-on learning data science foundations and building with Python. So I highly recommend these. I've done a lot of the badging myself, and I find it really helpful. Okay, so it looks like we have a mix of students and professionals here today, which is perfect. So if you're new to data science, or you're a developer learning to or looking to learn to dabble a bit and incorporate machine learning models into your projects, probably the first question that might cross your mind is, where can I find data sets? Where can I find data sets that are publicly available and that I can actually access and use? So here's two resources for finding data sets. The first one is Kaggle, and the second one is Google. So Google has a ton of public data sets available. Kaggle also has an enormous amount as well. You can also look on state and government websites. So you could look at United Nations or the health department. There are certain data sets that government entities aggregate and make publicly available. So there's a lot of data sets out there. And if you're looking on their entities website specifically, there will be a place to search for data sets there as well. So the first thing I want to kind of talk about is, so again, this is an extension from our bias in visual and voice recognition software panel discussion that we had a few weeks ago. And so what we're talking about today is AI fairness. And so I kind of want to do a brief overview of what that means and what we're looking for, and so you can get a better idea of what the toolkits are actually doing when they're mitigating bias in these data sets. And if you're having any issues hearing me or seeing me at all, try refreshing your browser. I just want to make sure, can you all see and hear me? So if someone wants to give me something in the chat here. So I just want to make sure you can all see and hear me okay. Okay, perfect. Cool. Sometimes it freezes. Okay, so, okay, perfect. Yep. So if you're having any trouble, go ahead and refresh your browser. That's the fix for any crowdcast issues. Okay, perfect. So to start with, we're going to talk about AI fairness. So what is AI fairness? So there's kind of three pillars, foundational pieces that you want to think about when you're building trustworthy AI pipelines. So to start, I think a lot of times we think about AI and machine learning as kind of this mystical being where there's all of this magic going around in the background, and it's really not. The capabilities of artificial intelligence are not hidden. So the intelligence of these machines that we're building and working with is undergoing a major transformation by continuously self-learning improvements. But at the end of the day, we are the ones training them. We are the ones providing data for them. So any bias that we find in our data models is not spontaneously generated. It's created from the data or the algorithms that we're creating for our AI machine learning programs. So there's a lot of things that are changing, but AI models are still a bit of a black box, and their decisions are often questioned by clients. So research is moving faster on improving and optimizing the algorithms, but this isn't enough to correct the problems that we're seeing and gain the confidence of our clients that we want to see. So conversations around building trust on AI often are a point of interest for developers, sales, marketing teams who are directly working with clients, data scientists. So that's kind of why it's really important. These are pain points and conversations that we're seeing in all areas within the tech space. Oops. So imagine owning a computer vision company that builds AI classification models for people in the healthcare industry, for instance, to diagnose cancer using MRIs, CT scans, and X-rays. So it can be really difficult for a doctor to rely on the diagnosis suggested by an AI model when a person's life is involved, right? So a lot of times working with technology and different software and data models, it's not always a matter of life and death. With medicine, it definitely is. So it's really important to build trusted AI pipelines, and it's only going to continue to become important with AI applications as we progress. So taking a look at the 3 pillars for building trustworthy AI pipelines. So the 3 pillars that we're looking at that are really the most important pieces for making sure that we're building AI pipelines that our clients can trust is looking at fairness, explainability, and robustness. There we go. So taking a look at the first one, AI fairness. So unfair biases can exist in the data used to train models, as well as in the model's own decision-making algorithm. So there's actually multiple places where, bias can exist in creating an AI model. Fairness emphasizes the identification and mitigation of these biases that are introduced into the data. That's a way of ensuring that the model's predictions are fair and do not unethically discriminate against any particular group or demographic. We can see this, for instance, in visual recognition software. Think of soap dispensers, for instance. When these things were being created, you could tell that the data that they were using did not include data of those with darker skin tones, which is why soap dispensers, automatic soap dispensers, they don't work for everyone. They don't recognize everyone as being a viable hand to dispense soap to. We also see this with voice recognition software. So when we're using things like Alexa or Google Assistant or Bixby or whatever your AI assistant is, it doesn't understand all accents, especially thicker accents from different demographics globally. So what we want to make sure that we're doing is that we're creating programs that work for everyone. And the 2 places to focus on are making sure that different demographics are present in the data that we're introducing to train the model, as well as in the model's own decision-making algorithms, making sure that these things are taken into account. So the second pillar we want to look at is explainability. So explainability shows how a machine learning model makes its predictions. It's going to give an improved understanding of the model by clarifying just exactly how the model works. So it's essential for data scientists in detecting, avoiding, and removing its failure modes. So to subject matter experts and customers for earning public trust in the algorithm and for introducing effective policies to regulate the technology. And the third pillar is robustness. So robustness is going to measure the stability of the algorithm's performance when a model that's deployed in the real world is attacked and noise is introduced into the training data. So it characterizes how effective your algorithm is while being tested on the new independent but slightly similar data set. So this is going to ensure the algorithm of the model is able to handle unseen disrupted data. So it's going to address the questions of estimating uncertainties in its predictions and whether the model is robust or not. So to build trusted AI, at IBM Research, they're developing diverse approaches on just how to achieve fairness, robustness, explainability, accountability, and value alignment, and how to integrate all of these things throughout the entire life cycle of an AI application, So not just within the data set, but within all the entire life cycle of building an application from end to end. So we have 3 open source toolkits. The first one is what we're going to be focused on today. That's the AI Fairness 360. We also have AI Explainability 360 and Adversarial Robustness 360. So we have a toolkit for each of the 3 pillars. Oops. There we go. We have a toolkit for each of the 3 pillars for building trustworthy AI pipelines. So the first toolkit we're going to look at that we're going to be building with today is the AI Fairness 360 toolkit. This is an open source toolkit that can help you examine, report, and mitigate discrimination and bias in your machine learning models throughout the application lifecycle. So it contains over 70 fairness metrics and 10 state-of-the-art bias mitigation algorithms that were developed by the research community. And it's designed to translate the algorithmic research from the lab into the actual practice of domains, ranging from finance, human capital, healthcare, and education. We're going to be looking at finance today. So the next toolkit we have is the AI Explainability 360. And this, again, is an open source toolkit. And this is going to allow you to understand how machine learning models predict labels by various means throughout the application lifecycle. So the Explainability toolkit contains 8 state-of-the-art algorithms for interpretable machine learning, as well as metrics for explainability. It's designed to translate the algorithmic research from the lab into actual practice, just like the previous toolkit, and again, covering domains such as finance, human capital, healthcare, and education. So the last toolkit we have is the Adversarial Robust 360 toolkit. This toolkit was designed to support researchers and developers in creating novel defense techniques, as well as in deploying practical defense of real-world AI systems. So for developers, the library provides interfaces that support the composition of comprehensive defense systems using individual methods as building blocks. Oh, it looks like I have this twice. Let me just check and make sure we don't have any questions here. Okay, cool. So again, if you're joining late, I have resources here of where you can find publicly available open data sets. So we're going to be focused on the AI 360 toolkit today. So what I first wanted to show you is the actual architecture. So what we're going to be doing is adding a file to our Cloud Object Storage within our instance of Watson Studio. We're going to be working with Jupyter Notebooks and Apache Spark. And for today, we're going to be focused on the AI Fairness 360, but you also have access to the other toolkits as well. So this is the architecture for the actual project we're working on today. So today we're going to be focusing on credit fairness. So just an overview of the flow. So it's pretty simple steps. I'm going to walk through and show you all of them. But basically, in order to use any of these toolkits, you're going to log into your IBM Watson Studio account. You're going to, if you don't already have an instance of object storage, you're going to create one, and you're going to create a new project. You're going to upload your CSV data file to the IBM Cloud Object Storage. You're going to load the data file into a Watson Studio notebook. And then you're going to install the AI 360 Toolkit and into your Watson Studio notebook, and then you'll be able to see the visualization for explainability and interpretability of the AI model for the three different types of models. So that's kind of a general overview. Here we go. So for the AI Fairness 360 Toolkit, here are, I just wanted to show you, these are all of the resources we have. And again, there's 3 different toolkits. This is just for the AI Fairness 360. We have Python API documentation. We have the Python code or the R code for the actual toolkit. We also have demos and tutorials. You can view different Jupyter notebooks that provide working examples of bias detection and mitigation in sample data sets. You can contribute to Jupyter notebooks as well and add new metrics. So there's a lot of really great resources in here. So what we're going to start with, we're going to go ahead and get started. So if you haven't already and you want to follow along or do this at home, you're going to want to click the button at the bottom of the screen and either create a free light tier cloud account. This is what the login looks like. Or if you already have one, feel free to log in. The other thing you're going to need, let me go ahead and throw in the chat for you here. Okay, there we go. The other thing that you'll need in addition to your cloud account is the GitHub repository. So if you click on the code pattern there, it'll open up a page for you. And you're going to click Get Code. And it's going to take you to the GitHub repository. So when you open up the code pattern, you'll click Get Code. It will link you to the GitHub repository, and then you're going to want to go ahead and clone this repository. So while you're doing that, let me get my things open here. And if you're not able to follow along right now, I have everything step by step in the slides. So if you get behind or you need a second to catch up, everything is step by step in the slides. I'm going to show you live how to do all of this. So let me just close a few things. Okay, there we go. Switch my share screen. Okay, share. Okay. So when you log into your cloud account, go back, you should be at this view here. There we go. It's a little slow. I have been having some issues with my internet since the blackouts a few weeks ago. Okay, perfect. So you'll see your dashboard here. the next thing we want to do is go ahead into the search bar and type in Watson Studio. So I'm going to open up my Watson Studio here. If you don't already have a Watson Studio, you can click here at the bottom. And you're going to want to create a new instance of Watson Studio. And again, you're going to, the default is the free light tier. Again, it's free for you to use. So there's already a default location set. You'll just select the light tier. And then what I like to do is just put like my initials or something. Your default resource group should already be selected here. Unless you're working with a team, you probably only have one resource group. And then you can go ahead and click create. And then when you click create, it'll create your new instance of Watson Studio, and you'll see this view here. So there's a lot of resources in here as well, but what we're going to do is we're going to just click get started. This is going to open up our view in IBM Cloud Pack for Data. Okay, so the next thing we're going to do is create a project. You have two options here to create an empty project or create a project from a sampler file. We are going to create an empty project. I'm going to call this project AI Fairness 360. So the next thing you'll need is a cloud storage instance. If you don't already have one, you'll have the option to create one. If you do already have one, you should be able to find it in the drop down here. And once you've associated your cloud object storage instance, you're going to want to click create. Perfect. So now I have this new project here. As you can see, I don't have any assets or anything in here right now. So this is where you're going to want to clone that repository if you haven't already. So I have my project here. Let's see what we're on. Okay, cool. So the next thing what I'm going to want to do is go to my assets, and I'm going to want to browse. So I put this into a, I already have this here, but I have an AI Fairness 360 folder. Here's my project. So when you go to your project, you're going to click into your project. You're going to go into data, and you're going to go into assets. And you're going to want to add both the zip file and the data. So I'm going to add those to my project. Okay, so now my assets have been added to my project. The next thing I'm going to do is create a notebook. So since all the work we're going to do is going to be in a notebook, so when you click this Add to Project button at the top, We're going to click here. We're going to create a new notebook. Now, if you look in your, let's see here. If you look into your project here and you look at your notebooks, we have, so make sure you can see this. We have 3 different notebooks here. So we have in processing, we have post processing, and we have pre-processing. So the first thing we're going to do, just it's down. Just refresh for a second. Okay, so sorry about that. Going a little slow. Just need to pull something up here. I just want to check in with you while I'm getting everything together here. Was everyone able to get access to their cloud account and clone the project okay? Go ahead to add to the chat. So the project we're working on with the AI Fairness 360 Toolkit. Oh, sorry, I don't want you to have to look at that. There we go. So what we're going to be doing here is removing bias from the machine learning models and ensuring that our predictions are fair. So there are 3 stages in which the bias mitigation solution can be applied. That is in the pre-processing, the in-processing, and the post-processing. Let me just show you. Okay. I think this will be helpful. Let me show you a diagram here in the repo, even though you have access to it. So the mitigation algorithm can be applied in 3 stages of model building. So we have the pre-processing, the in-processing, and the post-processing. So in the pre-processing, we have data bias checking and bias mitigation. Sorry about that. We also have, when we're testing and deploying, we're also able to model bias checking and bias mitigation, and then we have data bias checking. So our pre-processing is our data bias checking. So we're checking our data for bias and mitigating any bias we find. The in-processing is where we're checking our model for bias and mitigating any bias we might find. The post-processing is the data bias checking. So we're checking the feedback for any potential bias that we can mitigate. So I want to show you quickly to the architecture diagram. I posted a similar architecture for this. So we have our Watson Studio instance, our object storage. Then we are adding our CSV file. we're running our AI Fairness 360 toolkit, and it's running on Apache Spark. So let's go back to our notebook. I just kind of want to explain that and make sure that's clear before we jump in. So when we're looking at our 3 notebooks here, so when you look into your project here, we have in processing, post processing, and pre-processing. So the first notebook I want to look at is the pre-processing. So when we come here, I'm gonna give it a name, identify and remove bias, and this is pre-processing. Oh. And what we're going to do is we're going to add our notebook from our URL. So if you go to your, maybe I have it pulled up here and I can show you. Now that we've cloned the repositories, so we have access to the data that we already added as assets, the next thing we're going to do is we have our 3 notebooks here: pre-processing, in processing, and post-processing. So what I'm going to do here is I'm going to just copy this link address, and this is going to allow us to add from a URL. So this is just linking to the notebook that's within this repository and within the project. So what I'm going to do is, oh, something happened. Identify and remove bias pre-processing. And then I'm going to add that pre-processing. So it gives the whole link of the repository, the notebook folder, and then the pre-processing Pi notebook here. And then I'm going to click create. Just a second to load here for us. And so what's nice about the notebooks within Watson Studio is you can keep your any notebooks that you create within Watson Studio to create any applications. Makes it really easy to access all of your assets end to end for an application within your the cloud portal. Okay, perfect. So the first thing we're going to do is, if you look here in the corner, it says not trusted. So what we want to do is click that. Trust this notebook. A trusted Jupyter notebook may execute hidden malicious code when you open it. So these are notebooks that we're providing for you so you can trust them. So I'm going to go ahead and click trust. My project's going to reload. My notebook's going to be reload. Perfect. The next thing I'm going to do is, if you see this 0100 here, it says find and add data. So if you scroll down here, we have our pipeline encoder, which is going to be loaded as we work through our notebook and load it that way. But what we do want to do is insert our data to code. So your data here, not sure why this is not. I'll try to refresh. Okay. I did something when I restarted this. So I'm going to show you here. When you click here, it should say pandas data frame. So what you're going to want to do is scroll down to where I have this note here for you. It says this is where you import your data frame, delete everything in this cell below this comment, import your data with find and add data. So what you're going to want to do is select all of this and delete it. And then you're going to want to select insert to code pandas data frame. So added this all here. And then what you can do is you can run your notebook. So this, I don't know why this is happening. Let me open up my my other project. I may have moved the file, and it might not like that. Let me just open up my other project here. Preprocessing. And just for reference, when you go back to a notebook that you've created, once you click on it in the details like I did in my list of projects, you're going to want to click this pencil here. It says edit, and that's going to take you to where you can go back and run that notebook. This is why I screenshot everything. So if anything ever doesn't work, I at least have a copy for all of you to follow along. Okay, so this is my previous trusted, trust. Okay, connected, perfect. Go to my data set. Okay, let this reload. Okay, so I'm going to go through and let's just start from the beginning. So this notebook is going to demonstrate how to identify and remove bias from this fraud data CSV that we are providing. So we're removing bias during the pre-processing stage for this particular notebook using the AI Fairness 360 toolkit. And we're doing that by adjusting the weights. So we have a pre-processing algorithm here. This is a bias mitigation algorithm that's applied to our training data. So I'm going to go ahead and run this cell here. And we have these service credentials provided for you. We're going to run this next cell here. Let's see here. So just for reference, if you haven't worked with notebooks before, what's actually happening is when the notebook is executed, each code cell in the notebook is executed in order from top to bottom. So if you accidentally, press 2 quickly, you can see the little star here. So the second line isn't going to run before the first line. So it is going to run it in order. Each code cell is selectable and is preceded by a tag in the left margin here. So depending on the state of the notebook, this can be blank. That indicates when a cell's never been executed. A number. This number represents the relative order this code step was executed. So as you can see here, we have 1, 2, 3, 4, 5. And a star indicates that the cell is currently executing. There's 2 ways to execute your code, which you can do one cell at a time here, which is what I'm doing here with this play button to run the code. You can also run it in batch mode, which will run everything in sequential order by going to cell and then run all. So let's just take a look here. Okay, so we left off here. Okay, so let's run our next line. Okay, so this is this label encoder here. This is what's processing that zip file here. And also, as you can see here, we are installing our AI Fairness 360 with this line here. So now that that's complete, we're going to import TensorFlow. So I can run this line. This line is just updating our version of TensorFlow. And this is going to import pandas and set some of our variables for us. So this is, there we go, updating our version of TensorFlow. So this is going to import our binary label data set metric, our binary label data set, our markdown and display, and we're going to import, you see here, this reweighing. This is going to be imported from our AI Fairness 360 toolkit from the algorithms, from our pre-processing algorithms. So this is the algorithm that we're using, this reweighing algorithm. So I'm going to run this. Successfully installed TensorBoard. Okay, so I'm going to run this block of code. I'm not exactly sure what happened. All right, we'll fix this up. Okay, so the next thing we're going to do is this is the cell I was talking about. So what you're going to want to do, and I already have my code in here, but what you're going to want to do is, like I showed you, is remove everything from in here. Then you're going to want to, with your cursor in the cell, click Insert to Code Pandas data frame. There we go. Oops. Let me fix that. Okay. This brings in your IBM API key, your auth endpoint. So this is going to access your IBM Cloud Storage and include your credentials. So next thing I'm going to do is, now that I have added my fraud data as a pandas data frame here, I'm going to run this cell. And this is the output we can see here. So we have gender, married, education, and fraud risk. So it looks like non-married male is a risk. A married male is safe. So this is running our output here. So now what we're doing here is we're just setting some variables. So we are having our privileged groups gender as 1, and our unprivileged groups gender as 0. We're setting our favorable label to 1 and our unfavorable layer to 0. So we can just run that. So now from here, we're going to import our pre-processing from our scikit-learn. We have our categorical columns of gender, married, and fraud risk, which we can see here from our data. And we have our data encoded here. And what we're going to do is use our scikit-learn label encoding to encode our character data. So we can run this cell. I don't know why. I don't know why I'm having an error now. Fix this error earlier. I'm not sure what this is. Let's see. Let's go back. Okay. Okay. So let me check. Is right here. Is anyone else in get the same error? So Michael, you're getting that error too? Okay. I just updated the notebook earlier and was running it fine. Is anyone else getting that error? I just want to check. Can we upload the notebook? Yeah. Upload the notebook. Yeah, you can use the upload feature too. All right, let's see. Okay, so I updated this. Let me figure out what's going on there. Let's try here. So this is the in processing stage. Let me just run through here and check to see if we're getting, there might be a piece of data somewhere that's missing. So the data here, run it. Same thing with our unpublished groups. Let's see. To start this kernel. Okay. Interesting. I think I may have done something. I was fixing another error and updating it, and I may have gotten something snagged in there. Let's try here. So just to show you here, we have our assets here. And as you can see, I have all my notebooks here. So what you're going to do for each of these 3 notebooks, in processing, post-processing, pre-processing, what you're going to do for each notebook is you're going to create a new notebook for each one. And Michael, yes, so if you want to just drop the file from the repo that you cloned locally, you can do that. You can also add it from the URL here. But so for each of those notebooks, you're going to create a new notebook and add them. And then we're going to work through them the same way. So as you can see, here we go. So this is our, do it again. What is this? Okay. As you can see here, there we go. I have a notebook for each of those notebooks from the data set. So let me wait for a second. There we go. Yeah, so I have the in processing, pre-processing, and post-processing. So what I'm going to do here in processing, again, so I'm opened up this notebook that I already created. I click this edit pencil. Okay, so I already made sure that I let it know it was trusted. We have our data sets here. So if we scroll down to this cell where I have this note here, this is where we remove and then remove the code that's there and then insert our pandas data frame here. So let's just start at the beginning here. Okay. Just needed to refresh this. Okay. So we're running our zip file here. So here we're going to install our pipeline encoder from our zip file, and then we're going to install our AI Fairness 360 here. There we go. We're going to import TensorFlow. We're going to update the version. And here we're just going to load all the necessary packages from our library. So everything we need from our AI Fairness 360, as you can see here, we have data sets, metrics, and again, we're importing and loading our binary label data set metric, our classification metric. We have a compute Boolean conditioning vector. So this is loading everything we need from that 360 toolkit. Okay, and then again, this is where you're going to insert your data here. So let's run this. And again, we have that we have risk. We have married male, non-married male with an education is risk. Married is not a risk. So it's just showing us from our data that we already have. And then let's keep moving. Okay. So we're going to set some variables for our privileged and unprivileged groups and our favorable and unfavorable labels. Let's see. This is what I'm going to do. Go back up. I don't know how that got set to 2. Let's run this now. Let's try to run this again. Perfect. Okay. So for some reason, this got switched to a 2. If any of you are having that issue too, go ahead and put a note because I've been working on updating this this code pattern for all of you, and I will go back and double check again to make sure that that is set. But the issue basically I was having was just a variable error. For some reason, it imported differently in different notebooks. That's okay. We have it fixed now. Okay, so we have our output here, our output here. Okay, our count unique. Our top was male, not married, not enough information for education, and it's not a number. So those are our yes and no's. And then fraud risk is safe. Frequency, we have our mean. Okay, so let's go back and try to set our variables for our groups again. Okay. Then again, we're going to import our pre-processing here. So this is where, so I'll check on that, the pre-processing kit, to make sure there's an issue between these two, and the other one. I can take a look at that for you. Okay, so we're importing our pre-processing from our scikit-learn kit. This is going to use scikit-learn kit's label encoding to encode our character data. So you can see here. So we have our feature, and then we have our mapping here. So for gender, our female is 0 and our male is 1. For our feature of married, our mapping is no is 0, yes is 1. And for our feature fraud risk, our risk is 0 and safe is 1. So we can see here. Okay, so let's go ahead and print our validation data encoding. Okay. And then here we're going to create our binary label data set, so we can use it. It can be used by our bias mitigation algorithms. So we're just creating our binary label data set here. So we can run here. And then we want to display in Markdown. We want to print out our shape of the training data set, the training data favorable labels, our unfavorable label, the data protected attribute, and the privileged protected attribute, and then our unprivileged protected attribute. So our privileged protected attribute, we have 1 for male, 0 for female, and training data for our unprivileged protected attribute, we have 1 for male and 0 for female. Let's go ahead and run this. So we can see our trainer dating details here with the shape of the training data set, and then our details as well. So we're going to split our fraud data set. Go ahead and run this. And then this is going to be the metric for the original data set. So we have our binary label data set metric. We have our training set, difference in the mean outcomes between unprivileged and privileged groups. And then we have our test set, the difference in mean outcomes between privileged and unprivileged groups. So let me go ahead and run this. So here's our original training data set here. We can see our values here. So this is the difference in our outcomes between our privileged and unprivileged groups in our training set and then in our test set. So here we're going to take a look at our scaled data set. We want to verify that our scaling does not affect our group, the group label statistics. So again, in our training set here, we're going to take a look at the difference in mean outcomes between privileged and unprivileged, and in our test set as well. So let's go ahead and run this. So these are our scaled data sets. So we can take a look at the difference here between our our original training data sets and our scaled data sets. And this is just going to verify that the scaling does not affect our group label statistics. So as you can see here, these numbers are the same. So our scaling is not affecting our group label statistics in any way. So now, next thing we're going to do is build our plan classifier without debiasing. So we're going to load our post-processing algorithm that equalizes our odds. And then we're going to learn parameters with debias set to false, because we're building this plan classifier without debiasing. So I'm going to go ahead and run this. Okay. All right, we have our output here. And then we're going to apply the plane model to our test data. Let's run this here. And then the metrics for our data set from our plane model without debiasing, we're going to print out this data here. So let's run this, and then we can take a look at our data that we're printing out here. So we're running this, and we can take a look at our model without debiasing data set metrics and also our classification metrics. So we have, again, our training set and our testing set. So this is showing the difference between unprivileged and privileged groups in our training set, and again, in our testing set. And this is our model without debiasing. And these are our classification metrics without debiasing. So the next thing we want to do is to apply our in-processing algorithm based on our adversarial learning. So let's go ahead and run. Again, we have our learn parameters with debias set to true. So before we ran our debias model with our learning parameters with debias set to false. This time we are setting it to true. So we have our scope name, debias classifier, and debias set to true. So let's go ahead and run this. And then we can run our defraud data set training here. Here's our output. And then the next thing we're going to do is apply the plain model to our test data. So let's go ahead and run here. So now we're going to look at our metrics for data set from the plain model without debiasing. And then we're going to compare them to our metrics for the data set from the model with debiasing. So let's go ahead and run this. We can look at our output here. So we can take a look at our model without debiasing. These are our data set metrics. So the difference in the mean here is negative 0.51. And then with debiasing data set metrics, the difference in the mean outcomes is 0.8. And that's in our training data. And then in our set data, we go from 0.5 to 0.89. We also have our model without debiasing classification metrics that we can look at the difference within here too. So in our test sets, we have our classification accuracy without debiasing is 78.78. Our balanced classification accuracy is 0.785. Our disparate impact is 0.173. And our equal opportunity difference is 0.57. We also have our Thiel index here. And we can compare those with our model with debiasing classification metrics. We have a classification accuracy again. Here it's 0.6. Our balanced classification accuracy is 0.58. Our disparate impact is 0.1 from 0.17. And our equal opportunity difference is 0.714. So what we looked at here, moving through our notebook and processing our data, identifying bias and mitigating that. So what we did was we observed how to use the AI Fairness Toolkit to eliminate bias during the pre-processing and in-processing stages of model building and development. There's definitely something going on with, so we're looking at our in-processing notebook here. I need to fix whatever's going on in this pre-processing notebook here. There's something, DF data 1, DF data 1. Oh, I don't know how this got set to 2. All right, so let's go back. Let's run this. Okay, so Michael and anyone else, I have to look back at the chat in just a second. Okay, so the issue was, and I'm gonna go back and fix this again because I fixed it, but for some reason when I load a new data set Anyway, the issue is making sure that your variable here, this df data 1, making sure that this variable is consistent. So the issue was here, we had df data 1.copy, and we had our fit transform df data 1 here, right? But this was df data 2, so that's what the issue was that we were having here. And I just fixed it, but now it's importing the data as separate. So I'm going to add a note in the worksheets here. I'm sorry, in the workshop slides here, just to have you check those when you insert your code, just to make sure that it doesn't switch from 1 to 2, because that seems to what's happened when I started a new project here. Okay, so let's go back. Here's our output here. Let's keep running, setting our privilege groups. Okay, so our features and our mapping. We have our fit transform, creating our binary label data set. Then we want to display everything in Markdown. So here's our training data details. Let's see. Difference in mean outcomes between unprivileged and privileged data sets, or I'm sorry, groups. Okay, so this is where we are reweighing our unprivileged and privileged groups. This is where we are training that data set with our reweighing transform. So this is where we are taking our training data set and reweighing our privileged and unprivileged groups. So we're going to train our data sets here with our labels that we created. Let's scroll down. Okay, and then we'll run this here. And then we have the difference in mean outcomes between privileged and privileged groups, as you can see here, is 0. So just to, I know I kind of went back to this to take a second to fix it. So basically what we're looking at here is this number here. The difference in mean outcomes between privileged and unprivileged groups was negative 0.37 here. This was prior to reweighing our data set with our training data set with our privileged and unprivileged groups, and then training that data set with our labels. Once we run, once we are done training our data, we run this again to look at the difference in mean outcomes again after we've trained our data set. As you can see, the mean outcomes between privileged and unprivileged groups is 0. So this is showing, what this is showing is that there's no there's no unfair advantage between the unprivileged and privileged groups. So we took data that contained bias. We identified where the bias was in our data set. We created, in our preprocessing data, we set our, it's a little too far. We set our variables for our privileged and unprivileged groups and our labels, and we used our scikit-learn label encoding to encode our character data. And then we used our AI Fairness 360 reweighing feature to reweigh our data set and train our data set with the reweighing transformation, and that was able to remove the bias from our data set. So when we take a look at the difference in the mean outcomes here, we can now see that there isn't any. And I wanted to show you a few. In the pre-processing notebook, where did you define df data 1? Okay, so let me just show you here. So if you go to the code block that has this comment here, the comment that says this is where you import your data frame, you know, this is where you're going to do your stuff, has 3 comments here. It's right after we import pandas and our binary label data, data set metrics. At the very bottom, it says this is where you're going to make sure that this is your DF dataset 1 and your DF dataset 1.head. So right here. And basically what you, this could be anything, but what you want to make sure is matching is within this code block here, whatever is labeled here, this DF dataset, this pandas that reads CSV and setting the head, you want to make sure that that matches this scikit-learn import preprocessing here. Here, setting deep to true, and within our for loop here. So these are kind of the 4 lines of code that you want to make sure are matching. So these 2 inside this block, which is right below your privilege groups, and then these 2 at the bottom of your block where we inserted our code, our pandas data frame. Let's see. And I want to show you here. So I'll make sure to add a note in there because I think depending on in what order you add the assets to your different notebooks, I think it's changing the number. So like I said, I'll add a note to just check and make sure that those variables are the same. And I will, on my end, see what happens when I update the notebook in the repo again, and then re-pull it and do create a new notebook again and see if it's still changing that variable number. But I wanted to show you here. So this is where we're taking a look at our results. So again, we ran our pre-processing. So this is where we're identifying and mitigating bias in our pre-processing data. So again, we're looking at before our pre-processing, this difference in means outcome between privileged and unprivileged groups. And then we can observe that privileged group had 37% more chance of getting a favorable outcome because of the bias in our data set. So that had nothing to do with the algorithms. That was specifically looking at just our data set. So just the data set that we were working with had a 37% more favorable outcome based on bias just in the data set. That's not even taking into account the model. So after our pre-processing, the difference in mean outcomes, like we just looked at, is 0. So we are able to apply our bias mitigation algorithm and completely remove the bias that existed in our data set to make sure that there's no unfair advantage between privileged and unprivileged groups. Now, this in-processing results, this is the second notebook that I created and showed you. There are 3. We're just going to take a look at the first 2 here. So again, we can take a look at the difference of the training set and the test set of our model. And this is taking a look at our models, our machine learning models. So we can take a look at our model without debiasing, and with debiasing, we can compare the data set metrics and the classification metrics. And so basically what we're seeing here is we can observe that after applying that bias mitigation algorithm during the training of our data set, the equal opportunity difference has reduced from 17% to just 3%. So this is what we're looking at here, this equal opportunity difference. So it reduced the bias of our model after we applied the bias mitigation algorithm during training for this one. So before we were applying it to our data set, here we're applying it in our training of our model. And we were able to reduce that bias down from 17% to just 3%. So the average odds difference has reduced from 22%. You see here, this average odds difference here has reduced from 22% to 13%. So this is making our model unbiased to a good extent. It's mitigating our bias by a good percentage. There's a reduction in the numbers before and after debiasing the data set metrics. So if we're looking at these data set metrics here. So we're going from 53% to 38% and 25% to 2%. So that's pretty good numbers. We're not going to run through the whole post-processing notebook, but again, the data is there in the repository. But what you'll notice when running through the notebook for the post-processing notebook data, what we're looking at here, so we have our classification thresholds at the bottom, our balanced accuracy on the side, we have our original and post-process validation data that we're looking at in this chart. We have our equal opportunity difference, which we were looking at here in our classification metrics. So what we're taking a look at in this graph is we're observing that after applying our bias mitigation algorithm on our predicted labels, there's a change in the balanced accuracy and equal opportunity difference, indicating the fairness of the results. So as we can see here, so we have our balanced accuracy and we have our equal opportunity difference. As you can see here, they come way down here from where they started from. So it's just our licensing. Okay. So this code pattern, again, I'm a cloud developer. I do quite a bit with AI and machine learning. But for myself, what gets me excited is being able to quickly create machine learning models and hook them up to my applications so that I can easily make requests and actually make requests to my models and get a response back easily in my applications. But this code pattern is actually pretty useful for data scientists and developers, machine learning engineers, architects, business stakeholders, to allow them to make unbiased decisions on the basis of the model results. So, go back here. Sorry, my internet is a little slow. Like I said, it's been a little spotty since the blackouts. Let me just go down here. Just wait for this. There we go. Isn't this blackout? Okay, so we just took a look at that. Are there any questions? So while I'm kind of pulling the last few things together for all of you here, are there any questions any of you have for me? Go ahead and you can just post them in the chat while this loads. There we go. And if you would like access to, some more content, or if you'd like to check out some more cloud development and machine learning workshops, I have recordings, all my recordings on my YouTube. Feel free to follow me on LinkedIn as well. So a few things before we go. These will load. Yep, there we go. So I want to say thank you all for coming. Again, if you have any questions, feel free to post in the chat. I'd also, if you would be so kind, I have a very quick 2-question survey. Very, very quick. You don't need to put any personal information in it. But any feedback you have would be really helpful. I just put the survey link in the channel. Let's see what else do I have. And then I have all of the event resources at the end. So I have, again, a list of all of the links to all of the resources that we took a look at and played around with today. I also have the links to those data science certifications for anyone that is interested. I also have AI fairness resources here. So we have our IBM AI Fairness 360 Toolkit. I also have Google's Responsible AI Toolkit. We had a data scientist from Google in our panel. If anyone would like the link to the panel discussion, I can post that too if you would like. Let me just grab that for you real quick. And there we have a lot more resources from that too. Let's see. Here's right. Bias. Let's go down. Let me get it for you a different way. We had a lot of great resources there too. Let's see. Get that for you. We also have computers ready to poop out on me here. So here's some more resources from our friend at Google. And here are some really great AI ethics resources that we got from our panel discussion. Let me just get that link for you. There we go. Let's see. Let's see. Just. There we go. Here's the link. That's what I wanted. Okay. So this is the So if you would like, if you're interested in watching the playback from our Ethical AI panel, here is the link for that. There we go. Question. So link to your YouTube. So this link right here, this bit.ly link, let's see. that I posted up here, is the link to my YouTube channel. So I have all of my content broken up by, cloud development, Watson Studio, machine learning, OpenShift. I have kind of them broken up into categories. So the bit.ly link to my YouTube is where you can find all of my recordings, including this racial bias ethical AI panel that we had. I do have the recording there as well. This is the crowdcast for it if you're interested in following it there. Can you send out a follow-up with all these resources? Yes, I will send out a follow-up email with all of the resources. I make sure to send them out to everybody, and for anyone that wasn't able to come or that wants to access things later. Let's see, what else do I have? And then if you're interested in so these are all the places that you can follow us on social. So we always have a handful of workshops every month, tech talks. We have a lot of great content on Twitch. You can follow us on Twitter, YouTube. And again, so if anyone would like to connect with me, feel free to follow me on LinkedIn. You can also follow my YouTube channel. This will be uploaded to the YouTube channel as well. And like I mentioned earlier, I'm going to double check the data sets and find out why that variable is changing. And then I will make sure tonight that that's mitigated, even if it's just adding a note in the slides to make sure that you're checking. So are there any other questions or anything else I can do to help any of you? Feel free to post in the chat. And if not, feel free to reach out if you have any questions. I'm here to help all of you with any questions or anything that you may need some help with, or point you into the right direction of resources. So again, feel free to check out the Ethical AI panel from a few weeks ago, and we have a lot of great content coming up. Next week, we have an event with the Code 8 team that's worked on the IBM Debater data sets. So you can find that on the IBM Developer Meetup group as well. So that'll be next week. So I look forward to seeing all of you next time, and I hope you all have a really great rest of your day and your evening and an even better weekend. And feel free to reach out if you have any questions. But thank you all so much for coming. Bye.